Welcome to Hacking with WebSockets with Mike, Sergey, and Vaughn. Thank you.
Hello, test. Thank you. Hello, my name is Mike, and with my colleagues Vaughn and Sergey, we would like to take a brief trip through just one aspect of HTML5, WebSockets in particular. We'll start off with, I'll give us a quick 101, hopefully quick, just about what WebSockets look like both on the wire, on that protocol, as well as in the browser, what the JavaScript interface looks like. And from there, we're going to depart and talk a little bit about what the WebSockets look like on the internet today, as well as some predictions about where security problems could be in the use of WebSockets or the misuse of WebSockets. So the coolest thing about WebSockets is we finally get bidirectional communications in the web browser. So from the RFC, that's what it tells us, 3 really cool things: that duplex communication, untrusted code. So this isn't a surprise to anyone, of course, but we're still dealing with a web browser that may or may not be malicious or compromised or have other malintent. And as I mentioned, we'll see how many people are actually using WebSockets so far. Now, WebSockets came about because this type of bidirectional communication has been faked for a long time. Web developers obviously have a use for it, they have a need for it, and they've been doing things like long polling, XHR requests. But what these boil down to are kind of forcing a persistent long-term connections on top of RFC 2616. HTTP wasn't really intended for that type of use. And to a degree, some web servers weren't really designed with this in mind. You have 1 thread per request, so it would be easy to DOS them. Also, if you're talking from the browser's perspective, you have per domain connection limits. So that limits how many XHRs you can be launching or how many you can be using. And if you are doing polling, then you have to figure out some magic polling frequency so that you also don't accidentally DOS your own web server trying to get status updates, run chat messages, tweet updates, and so on. And all of this was just to be done so that the browser knows when the server has something ready to send to it. So there's 2 major aspects of WebSockets. There is the protocol layer. These are the data frames that are sending the data back and forth over TCP. That's what 6455 is. And then there is the browser connection. That's a very simple interface. And from a security's perspective, simple is good. It's easier to understand, it's easier to test, it's easier to look at. And what we'll see in a second in a demo is that you have 2 major event handlers. You have an on message that you get data coming into the browser, and you have send to get the data out of the browser. One of the nice things with WebSockets is that, yes, you can still send JSON, XML, other text-based formats over it, but depending on the browser or when implementation catches up with design, you'll also be able to deal with non-strings. You can do blobs or array buffers. And what that's going to help with sending things like images, audio, even video. You can even have a pure JavaScript audio decoder. And for that matter, WebSockets is just really a transport layer. It's a little bit more efficient than something like RFC 1149, but you really can send anything over it. You could send WebSockets over WebSockets if you wished, VNC. And these are some of the things when we start to talk about security that we'll come back to. But I think now, Vaughn, are we ready for a demo just to show WebSockets in action?
This little demo is entirely written on JavaScript on a client side and pipes my face through sockets, WebSockets from a Java-based server, captures the frames and sends them JPEG per JPEG, and this couple of lines of code here are basically changing data URL and making the illusion of a video. This is interactive, and you see I can pan it. And also there is a functionality that was supposed to make everything green, but it may work, may not, we don't know. But we don't need it probably because we drank so much yesterday, we are green already. Let's see if it works. Yeah, it turns everything into kind of 70s funky Andy Warhol style video. And the processing is done on a server. What this web app does is literally those few lines of code.
And another thing to highlight here is that if you can notice when it's flashing blue, that's when data is coming in and out. And the point about WebSockets here is this is over a single TCP connection. So we didn't have to do anything fancy with multiple XHR requests, or we're losing anything with as far as polling or a latency. And we're just faking this persistence of vision, so it looks like video, but it really, as Vaughan said, is just a bunch of sequential JPEGs. Anything else you want to mention on that?
No?
Cool.
Back to you, Mike.
So I will, as an aside, it is possible to bring WebSockets or WebSocket-like behavior into the browser. You can do so either with Flash using the WebSocket.js project, or you can stick with JavaScript using a WebSocket-like communication that's really just back-ended by long polling and XHR. But we just kind of mentioned this in passing because our focus is on WebSockets and HTML5. Because HTML5, one of the benefits or one of its intents is that we have cross-browser, cross-platform, no need for plugins, write once, run everywhere. And that's why we want to deal with WebSockets today. Most of the modern browsers support WebSockets, modern in this sense meaning something that was released or has been updated in the past 3 or 4 months. And it's on by default. In Opera, however, you do have to go and enable it through the preferences panel, but really simple to do. So in the demo that Vaughn just was showing us, there was just a few things going back and forth between the browser and client that I'll speak about more now. The WebSockets is going to start off with an HTTP handshake, very simple, very straightforward, and then it's going to switch that protocol to those data frames that are really these low overhead packets. And they're low overhead because they don't have the headers, cookies, or authentication mechanisms associated with web requests, HTTP. However, from a security perspective, they don't have the headers, the cookies, the authorization tokens associated with an HTTP request. So we'll come back to this a few times, but this drives home the point that WebSockets itself is just a transport layer. We're just shuffling bits and bytes from one endpoint to another. And the security of that protocol and how those bytes are consumed, that's where the real security failures are, or from your perspective, the interesting aspects. So the challenge, again, looks pretty familiar to a normal HTTP request. You have a connection asking to upgrade to WebSockets. And you have a WebSocket key to which the server responds with a challenge. This is a challenge response. And the challenge response itself is not something that's cryptographically strong in terms of identity. All it's intended to do is say that you are actually talking to an endpoint that speaks WebSocket. So it's not supposed to prove that you're still speaking to the same server you thought you were at the beginning of the connection, nor that the server hasn't been compromised, obviously, or is legitimately www.foo.com. The only thing here is identifying the endpoint to prevent some things like cross-protocol attacks, so that you can't turn that WebSockets and make it talk to an SMPT server, start sending spam mail or something like that. So just want to highlight that point that it's just about identifying the WebSocket, not identifying the server. There's some other policies that influence how WebSockets are controlled or how they perform in the browser. You can have the origin header associated with it, so this is good. You're probably already familiar with origin header from CSRF as a CSRF countermeasure. Another thing that the web has tried to learn from the past is the idea of mixed content. It's supposed to be the case that if you load a resource over a secure connection, HTTPS for example, you should not be able to establish a plain text WebSocket connection. And obviously this is something that is extra important in the days of ubiquitous Wi-Fi, let alone networks like at DEF CON. And then there are other things that are intended to minimize. The spec, for example, says, don't put too much verbose feedback into the reasons behind connection errors. Again, the intention to limit the use of WebSockets for doing things like host alives or port scanning. But again, that would just be a different way of using techniques, port scanning techniques that we already know about using image tags, iframes, and so on. WebSockets is just yet one more network layer or network request you can make within a browser. And it is supposed to work well with others in terms of other HTML5 technologies. For example, depending on the browser, web workers can also spawn WebSocket objects. When Sergey will talk a little bit about some of the potentials of denial of service that come with that. So real quickly, I mentioned simplicity and what it looks like in the browser. The WebSocket object has a few read-only attributes associated with it, some states regarding its connection state, and then 4 event handlers: close, error, message, and if I can read, open. And all you really need to do is tie a JavaScript function to one of those to get data in and out of the browser. And as you saw, it was that simple to basically recreate using WebSockets and an image tag our faked version of a HTML5 video tag, for example. Or we could have done the same thing with HTML5 canvas, but we just wanted to focus on WebSockets. So I'm going to wrap up a few more things about the protocol before we get to some more real-life examples. One of the things that we need to do now is we've seen how that HTTP handshake goes. There's a challenge response. Once that challenge response is finished, we move on to sending back and forth the web frame data, these data frames. And this is where you have minimum overhead of at least 2 bytes, which is much better than all the HTTP headers and cookies and so on. The first byte is going to be a fin flag, and a fin there just means is associated with the number of messages that are tied together, not like a TCP fin. You have an opcode that's going to tell you this is carrying text or binary, or it's time to close a connection, or I need to do a ping, keep alive, just to make sure that connection, that socket is still available. You have a flag about masking, which I'll get to in a moment, and then you have a length, which can be variable. So you can either have a payload that is 7 bits, or a 16-bit length, or even a 64-bit length if you have that much patience. The masking data is a flag that says that data coming from the browser is going to be masked, but data coming from the server typically isn't in a WebSocket connection. And the masking is important to use this term instead of encryption because it's not encryption. It is a 32-bit pseudo-random value. It's XORing the payload data, as you can see in the screen captures here. But what it's intended to do is to prevent the JavaScript layer from abusing a WebSocket connection and doing something like sending raw SMTP commands to an email server, sending spam, which is something that people have tried to get browsers to do for the past 20 years, if you look at the history of web security. And the reason so, the mask itself is part of the payload, part of that message. So even if you were to try to think of this as encryption, the decryption key is sent along with the message itself. So I want to make sure you don't have that misunderstanding that what masking is used for. And we actually have some comments a little bit later on about some of the implications masking may have about WAFs and IDSs. So you can maybe start thinking of that right now. The variable length, as I mentioned, up to 125 bytes of your payload. It will be encoded in those 7 bits. If those 7 bits equal 126, that's a special indicator that says this is now a 16-bit flag, or a 16-bit length. And if that value is equal to 127, that says it's a massive 64-bit flag. And 2 to the 64 is probably about how much porn there is on the internet or something. Who knows? This is future-proof. So that's why the 64 bits is so large. One side note here, however, is a number like 19 can be represented in 7 bits, 16 bits, 64 bits. If you think of UTF-8 and overlong representations, %Z0, %A7, and how historically that's been used to bypass filters or to get around IDSs or WAFs, there may be something here now. This point is just conjecture. We don't have a good solid example, but it's something to consider, something to think about. I mentioned how simple the protocol is. Here's basically just about all you need to dissect a WebSocket data frame using Scapy. So it is that self-contained, it is that simple. And really the only confusing part is just trying to figure out is the length 7, 16, or 64 bits. So As I wrap up, one of the things we're going to talk about is the security of WebSocket protocol and how it defines security. Well, one of the things that it does is leave that security up to you. As we mentioned, we want to emphasize WebSocket is just that transport layer. It's shuffling bits from A to B, and it's not making your JSON communications any more or less secure. It's not making your text communications any more or less secure. And that's where we're going to focus on and talk about a little bit more. So with that, I hand this over to Vaughn and talk about what he's got.
Thank you, Mike. Let's see what are the potential usages of WebSockets. We've seen many cool games implemented with WebSockets. There are some mobile applications that are basically front ends for the web apps. Also, few very interesting implementations of WebSockets that are in embedded systems. For example, the example above has capacity to provide WebSocket connection to PIC microcontroller, and with that, hobbyists can create all kind of crazy stuff that is controlled from a web. We've seen few professional usages that are, for example, this LabVIEW based sporting event measurement organizational tool. Most probably is going to be used in a day or two in London Olympics. So basically, iPad app talks to the LabVIEW server through WebSockets, and LabVIEW controls the measurement, sporting measurement equipment. To the best of our knowledge, there are 7 or 8 RFC compliant server implementations, maybe more. There are others that are catching up. They're in a good state, compliance-wise or feature-wise, but since RFC is pretty fresh, they are still catching up. There are almost all the programming languages now, major programming languages support WebSockets, and major JavaScript libraries like jQuery, Socket.io, and Node.js picked up WebSockets. We think that user capacity-wise, WebSocket applications will have similar to XHR-based similar performance user capacity-wise to the XHR-based applications, and their both will be basically limited to number of connections if it's a full duplex. If it's not full duplex and the persistent connection is not required, WebSocket usage in those applications may be overkill, since traditional HTTP reuses connection pool, and WebSocket is kind of one user to one WebSocket connection. Here we see this huge number, 25, sticking on the right, and that's what we saw on our little demo. That was the header overhead XHR compared to WebSockets if we were running the same webcam app, implemented WebSockets versus traditional HTTP. And this is basically, as Mike mentioned, is because of the compactness of the protocol. Handshake is done only once, and then consecutive packets can have overhead as low as 2 bytes. There is a little problem here. There is no compression supported by default. RFC lists it as optional. And there's hope that vendors, implementers will pick that up as non-optional and will help with bandwidth usage there. Now I want to hand it over to Sergey. He has more details and better data.
Hello. So we tried to figure out if there's anybody using WebSockets in real world. And there are two ways of doing it. One would be hire thousands of guys and they navigate to any website in the world and write down if they use WebSockets or not, or automate it, and we choose the second approach. We just took WebKit browser, headless, no need for UI, wrote a little wrapper, and basically the only functionality, almost the only functionality that application has is overloading in JavaScript API, overloading WebSocket constructor. So whenever that WebSocket constructor is being called, we got a line in our database. This approach might not cover some cases, like if there is a user interaction needed to instantiate a WebSocket, like somebody needs to click something to create it, but we think this should show us pretty much the real picture of WebSocket usage. And the results are that numbers are pretty frustrating. These numbers on the left are like ranges from 0 to 10,000, 100,000 line. In Alexa top, we pick 600,000 list. And like, as you can see, it's like around 10, I think. Only 10 web applications are using WebSockets on their landing page. And so, like, more website is popular, the less chances they are trying to change something and use something cooler than traditional HTTP. So some details. So in number-wise, it's like only 0.15% of websites from Alexa top 600,000 are using WebSockets on their landing page. But when we looked closer at the data, it turned out that 95% of those captured WebSocket connections were going to the same vendor. It was a customer support chat system, which is free, and like anybody was putting that chat widget on their page, even probably without using it. But when we got rid of that one single customer support chat system, the picture was that basically less than 1% were using encrypted connections, which is pretty, I would say, scary. You know, like, yeah, if we got rid of that noise making customer support chat system, the numbers are these. Like, among 600,000 websites, only like 20 something were using WebSockets on their landing page, which is again frustrating. Some details on like how they were using WebSockets. A couple of them were using it as a news feed, basically the only single direction, just a replacement for RSS probably, which probably makes sense if your web app is serving some news blobs frequent enough, and it doesn't make sense to reopen a connection. It probably makes sense to use it as a news feed. Actually, like a lot of Russian mainly and Brazilian, some shopping websites were sending back to some third-party marketing probably server your every mouse click and keystrokes on that web application, probably for some marketing uses, hopefully for marketing uses, and not for something malicious. Some question and answer websites using WebSockets to, like, you post your question on a website and then somebody's typing the answer already. You see he's typing the answer, but the answer is not there yet, so you can kind of track what's happening in real time. And stock price, I saw a very cool chart implemented purely over WebSockets, even like images or icons were being delivered to the browser over WebSockets. And some protocol usage. JSON was dominating. We saw XML being transferred back and forth over WebSockets. we saw some JavaScript lookalike data blobs, and I guess they were evaluating that function lookalike thing, right? Like without checking anything, could be potentially dangerous. Or somebody switched from old HTTP to WebSockets, but the way he was transferring the data, these name value pairs delimited with ampersand remains the same, so he just switched the transport layer. We saw a couple of interesting things, like some website was opening plain text connection to port 443. I don't know, probably maybe to bypass some proxy things or to make his customers think he's using encrypted connection by seeing that 443 magic number. And here we're trying to summarize what's holding down the wider adoption of WebSockets. And we hope that just more people would realize the benefits of using WebSockets and start using it. Now time for, no demo, later. So we just reviewed the adoption and like how people are using WebSockets in real life, and now let's discuss some security-related things. As Mike mentioned, WebSockets are just a transport, another transporting option between two peers on the internet. And WebSockets are not going to fix your existing problems on web applications, like if you have XSS or if you have CSRF, that would still be there. However, there are things around WebSockets that are being derived from HTTP, from like old-style data transfer, and we can start with mixed content handling policy around WebSockets. So points are that plain text WebSocket connection, attacker can sniff as easy as he would sniff plain text HTTP, which makes sense. And man in the middle is as effective as it was with HTTP. Neither client nor server could be trusted if connection is plain text, because if resource which delivered a code to the browser which is going to instantiate a WebSocket could be sniffed, then somebody can just overload WebSocket constructor or send and receive functions and tweak the data, or I don't know, forge the data, or do whatever he basically wants. RFC tries to take care, WebSockets RFC 6455 tries to take care of some issues by restricting WebSockets to by not allowing to create plain text WebSocket connection if code which instantiates the WebSocket was delivered over encrypted channel, so kind of no protocol downgrade. But unfortunately, only Firefox implements this policy. None of WebKit-based browser, including mobile versions, Opera doesn't implement it either. So there's things to improve in the browsers. Denial of service could be a potential. Denial of service attacks could be easily achievable with WebSockets, way easier than with HTTP, because browsers are treating WebSocket connection limits differently from HTTP, and like they are not limiting them by domains. Like for example, Firefox limits concurrent HTTP requests to HTTP connections to the same domain by 6 or 4, some low number. And with WebSockets, numbers are totally different. Like experimentally, I tried numbers look like this in this table, except in Firefox, it's hard-coded in settings. It's not hard-coded, it's default value is 200. We can change it from that about config window. And yeah, what can be done? Somebody can just send a malicious JavaScript code into someone's browser and like in cycle open or try to open 10,000 connections. either browser would die because of memory, or I don't know, file descriptor limit would hit, or something like that. Or even if it was executed in something like Firefox, once that malicious guy opened 200 connections, your other tabs that are using WebSockets won't be able to establish a connection, and you won't know what happened because there's no indication that you hit that limit. So one of potential uses. And on like server side, the same guy can pick the same bad guy can pick the same compromised browser, execute some malicious JavaScript, which would open WebSocket connections to another victim. And since numbers are pretty big, like starting from 200 to several thousand, having several bots or compromised browsers could knock down the entire WebSocket server. Stability-wise, while I was playing with browsers to find the limits, because they are not actually described anywhere except for Firefox, I was able to crash Safari, and it's pretty reproducible. I don't know if you can see the stack trace. Basically, to reproduce the crash, you open, I don't know, 300 or 3,000 WebSocket connections somewhere, and then close the browser and then reopen it. Safari would try to reload the last loaded page. There is a JavaScript which opens WebSocket connections. Those connections would be open, but since these cryptographically random values from OS function didn't generate the right number of hasn't managed to generate that entropy pool yet, and probably whoever is calling this function, that cryptographically random number, doesn't check the return value. Basically, Safari crashes. So it could be, WebSockets API could be a good starting point for example, browser bug, the bounty hunters, for example. So summarizing. What we've found that mixed content handling policy is not addressed yet properly. Firefox, for example, doesn't let create a WebSocket object inside WebWorker, which is another cool HTML5 feature. Message size is handled differently. Firefox recently bumped the limit both for outgoing and incoming connections, WebSocket messages, from 16 megabytes to 2 gigabytes, which could be pretty scary. Imagine somebody running a web server on embedded device, or vice versa, like client browser is running on iPhone, like handling WebSocket windows with 2 gigabytes of random data could be a challenging task. Some history around browsers, like Opera disabled WebSocket support by default. You can enable it. Mike showed how to enable it. Firefox disabled WebSocket support at some point in Gecko 2, I think, engine. And then because of some problems with cache poisoning of proxies, with handshake, WebSocket handshakes. Then Firefox changed when they enabled back the WebSockets, they changed the name to Moz WebSockets. So anybody would have that dummy stupid check if you can instantiate, if you can't instantiate WebSocket object, you try to instantiate Moz WebSocket, but they got rid of that limitation, so it's the same in any browser now. And yeah, IE doesn't support WebSockets yet. It supports in IE 10 preview, which requires Windows 8, and I don't have Windows 8, and so I never played with IE around WebSockets. And here is a demo, very simple tool that is gonna demonstrate how easy it is to use, start using WebSockets. So we built an application on top of WebSocket PP WebSocket server, It's C++ based using Boost, very cool server. So as you see, it's like 100. Ooh, I'm sorry. Yeah. Like only, what is it? 168 lines of server-side code and some code on client side, which should be injected in compromised browser. We don't discuss how. There are thousands ways of doing it, like XSS or man in the middle or social engineering. We don't discuss that. We just want to demonstrate how WebSockets could be used to control someone's browser easily and with minimum efforts. So I'll launch the server. There's my Chrome, which loads some page which which we assume is compromised and has that malicious victim.js JavaScript file included, and some dummy website. And latest Chrome allows you to see WebSocket traffic in developer tools. You switch to network, you select WebSockets here, and to reconnect. Yeah, we got our WebSocket connection. Let's see what's happening here. Yeah, and on the server side, we see that server accepted the connection from the browser. Now you can, I don't know, request for, I'll restart it. Here we have our WebSocket connection to that attacker WebSocket server. Chrome allows you to see the actual payload. We just sent ready, which is 5 byte length. Yeah. And on server side, you, for example, request for HTML or the rendered DOM. Or you can do, it doesn't matter really what you can do. We try to emphasize that it's over WebSockets, and cool things around WebSockets would be that none of mechanisms that's supposed to catch malicious traffic won't be able to do that, because as we know, there is no firewalls or IPS or IDS systems that are aware of WebSocket server, WebSocket protocol, and basically they just will miss this any kind of communication over WebSockets. I don't know, something here, we go back, we say, what did you capture, use data, or you can even navigate away. Something is wrong, yeah, whatever. We don't have internet connection here, probably some of JavaScript libraries were coming from outside. So yeah, you can launch a DOS, like point a yeah, I'm sorry, something screwed up. Yeah, whatever. Like, yeah, you have to click so far in Chrome every time you want to see the updated data in this tab. Re-click the actual WebSocket URL to have the updated data, and you can see all the WebSocket frames unmasked and in plain text. So let's go back to the slides. So what else? There are still some issues with handling WebSocket traffic by proxies, and Google conducted a survey or research in 2010, and it turned out that only 65% of web proxy instances would successfully communicate a browser with WebSocket server, and the main problem there is this connection upgrade. By the time those proxies were implemented, there was an RFC don't remember which one, 2068, yeah, which tells proxy developers to get rid of this connection upgrade header before they forward the rest of the data to the server they connected to. And on the other hand, WebSocket protocol requires to have this connection upgrade. So if proxy is not aware of WebSockets and doesn't know that it shouldn't strip off the connection upgrade, server would just reply with 400 because it's like incomplete handshake request. But good thing is, if you're using encrypted WSS protocol, encrypted WebSocket protocol, browser would, instead of this type of communication, it would send the connect keyword, and proxy would establish a tunnel between browser and the server, and so it won't access any of the information going back and forth, so it won't strip the connection upgrade. So for encrypted WebSocket servers, it's not that bad. And Fagan would tell you how, what tools are there available and how to look at the traffic and how to tamper data.
Thanks, Sergey. So we're going to torture you a bit more with our Russian accents, and then if anybody is awake and listening, we should pay attention now. Because we are going to talk security. We all want to make our WebSockets as secure as possible. And how do we do that? We need to understand how they work. We need to be able to play with them. And so far, not too many options. So far, for inspection, we will have like Wireshark nicely decodes the WebSocket traffic, unmasks, and can show the history. But of course, it's read-only, so we can't do anything with the traffic. But still, good step, and this been done recently, and good on your Wireshark. Fiddler has similar capability, can extract WebSocket traffic, unmask, and show the conversation. And as Sergey mentioned, latest Chrome developer tools will have support for WebSockets, and it's, of course, read-only. Won't do much help if you're trying to fuzz anything. There is one option. You can inject this piece of JavaScript at the client side and basically change sends and receives, capture for good or bad usages. Let's see what else is there as far as security. As Mike mentioned, WebSockets don't have cookies, authentication, form-based authentication mechanism, etc. The stuff that comes from HTTP. And developers, when trying to implement WebSocket applications, will be forced to either implement their own or mix and match with HTTP, and there are going to be new waves of different kinds of problems there. Another problem that we want to put an exclamation sign on is the unawareness of security devices like IDSs, firewalls, IPSs, and DLP solutions, unawareness of WebSockets, of those devices. Basically, this simple masking makes the traffic for those guys look like garbage, and they they will let anything go in and out. This is as far as we know. So if there are any vendors that have good stuff, just let us know. We'll be interested to see how it's done. Another issue, as Mike mentioned, about resurrecting the old Loki, is the good old problem of covert channel. WebSocket data frame can be used to transfer data alongside with legitimate WebSocket traffic in a way that nobody will see it. It can be the mask value itself, some of the reserved flags, or length field, or the way the length can be represented. You had lots of leverage there. So that's all I had, and the torture is over, so we are switching to regular good old English.
Thanks, Vaughn. We'll have a free screening of Red Dawn later if anyone really needs to. Just to piggyback on what Vaughn was mentioning about covert channels and the sources of entropy, I think to really drive that message home is you've got ideas of, imagine you have malware now that's using outbound connections. You have those command and control channels. It's great to use encryption, obviously, but you also need a transport layer that's going to be not seen by those DLP IDSs. And that way you could have WebSocket traffic that is using now this command and control for compromised hosts inside a system. In other words, those compromised hosts just look like a web browser making a connection back to that CNC server. And for all of those spots that you could, where your sources of entropy are for covert channels, the masking, variable length, reserved flags, those are also great points for fuzzing, just to see how that server responds to these in terms of its RFC compliance or in terms of capability. Because what we've seen is that you either got not even 200 lines of server-side code that Sergey was showing us in C++. You could have Node.js that's working as a server, and all these are going to have different attributes or different behaviors as they respond to these data frames. And of course, one of the other things to highlight is that in the very beginning, I talked about the HTTP handshake. The way this happens is that most of the WebSocket servers have implemented their own mini version of HTTP, of the HTTP protocol. So they really just have some hard-coded responses to these requests that come in. And depending on how the developers have decided to respond to these requests, for example, the path attribute, you could be requesting a WebSocket resource for /foo, but it could be now that all these developers are possibly reintroducing directory traversal attacks, path normalization attacks, because they've re-implemented basically Apache and IIS inside some JavaScript or inside some other type of code. Take your pick. So hopefully, and to wrap up, we want to be some good citizens of the internet and talk about how to use them securely. Well, unfortunately, as we saw in our current Qt crawler, our current view of the internet, just on that landing page, there wasn't really a critical mass of WebSockets yet. So one of the things that we're going to go back and do is have some bit fancier JavaScript that will try and interact with the web applications a little bit more and look for some more lower or deeper than that landing page, and so that we can find more examples. And what are great are examples of misuse of JavaScript. Obviously, you want to make sure WebSockets work with your architecture, or you understand what you're taking on. One of the points Sergey was making about denial of service is that an attack like Slow Loris is trying to create long-term persistent connections to drain the connection pool of a server. WebSockets inherently does that. Obviously, it does that by design, and that's the intent, but you just have to be careful what you're introducing. In the day and age, to an audience like this, we shouldn't have to say this third bullet point about don't trust the client. But considering that in 2012 we can still find more than a handful of web servers that have SQL injection and unsalted passwords, I guess it's worth reiterating here. And the final points I think I want to make on this aspect of secure WebSockets is what that protocol is. If you're using WebSockets is as secure as the way you're using your query string. If you're not validating that query string, or if your query string is prone to spoofing attacks, other types of replay attacks, depending on how it's identifying users or identifying data, that same thing is going to happen over WebSockets. One of Sergey's examples was somebody was using WebSockets, but all they did was take the query string, and rather than put that query string in a GET request, they were just sending that query string over the WebSocket connection and getting that data back. So these are the things this is what I think is interesting about WebSockets, is because we do have a new protocol, and now we have a new way of layering communications on top of that protocol. So we get to go back and look not how TCP/IP was, but how people started layering things on top of WebSockets. So final three ideas to leave with you is that there's nothing inherently insecure about using WebSockets. There's a lot of really good things you'll get performance-wise and ease of use-wise in terms of the light overhead for your browser-side JavaScript. Obviously, all of that, as I said, all the security you're applying to that query string still has to be applied to that WebSocket. And finally, what I think is going to be the really cool part are what those final notes that Vaughan was making about masking and covert channels and whether or not security devices are even aware of this. So this is basically taking your HTTP traffic, and if your IDS can't handle it in ROT 13, there's no way it's going to handle right now WebSockets just because it's unaware of it. And this is going to be good, useful both for attacking into that web server, putting the cross-site scripting, SQL injection, all those attacks, but as well as possibly, as we mentioned, outbound connections, malware, viruses, using this for just a new protocol that's going to hopefully become ubiquitous as HTML5 is more adopted, and therefore just harder to pick out those needles in the haystack of bad frames. So it is still evolving. The RFC has been updated just this month, and as we saw, there's varying levels of support within the different web browsers, but this is also the great time to start looking into the protocol, start fuzzing some of the server-side implementations. We, of course, intend to make those graphs, those Alexa graphs, a little bit more interesting, get some more data about and some more examples, and show you, here's how some people did it well, here's how some people made some mistakes. And with that, we thank you for your patience, thank you for your time, and I think we'll have a chance for questions. Thank you.